so the first thing you do is, sorry. By the way, this sudo is not necessary in most other computers. It's just that mine has as of late required that I use sudo for a lot of different things. So it's how do I say this? Yes, that sudo is just for my computer. You should not need to use it. Okay. Now we already have the JMAF running, and up to this point, this should be familiar enough for you. Now we're getting to the different stuff. So now we go to the mavros stuff that we saw earlier. And no, we didn't see this earlier, but we already sent you information on how to install it and have it running on your computer.
Yeah, we talked about that on Monday.
So this is going to be the Kaki mavros WS. And we have also sent you these files. So the one that you should launch is launch mavros SITL for the SITL files. This one is for the actual quadcopter. Yeah, we can later confirm if you have this. If not, I'll just update the repository with this one. By the way, this is after I have run catking build isolated. So everything's already been built before. Here, just. Yeah, now you're going to see a lot of different things, messages. Let it run a bit. And yeah, I believe that should be working enough. Sorry. Now, if everything's working, yeah, you see, partner IP. That means that we have connected to the drone. That's in the window in which you started running JMAFSIM. So in order to connect to the JMAFSIM, we can use current control. So in the place where you have current control, you open a terminal. And you run current control. Now, then you go to the menu, comlinks, and you should choose, yeah, I'll show you what this does. Basically, this is a UDP type connection, and it connects to the port 14550, 127, which is basically a port within the computer.
Hold flight mode.
And yeah, this should already tell you that within the simulation, you're here. Okay. So far, so good. Actually, with this, we could just how do I say this? Run this as using missions like before. But for now, we just want a local set point publishing. So we're going to go for a different way. Okay, so remember, I think you should also have the utility scripts in file within the yeah, you don't have the SITL launch mavros. I'll upload it to the utility scripts and so that you can have it as well. So anyway, this is the one that you want to run. As you recall, okay, yeah, here you have the waypoint radio. which means that it's going to wait until the what calculator is within 10 centimeters of the actual goal, and then it's going to wait about 20 seconds. And these are the filter values. I believe the alpha is the delta t actually. I'll have to check this out. But yeah, this is the epsilon, this is the omega n that you saw before. This alpha field implies that we would be sampling every 0.1 seconds. Although remember that this is relative because we don't exactly know at what rate the filter is being sampled due to the Ross sampling time not being necessarily the same at each time. So this is just a reference sampling time for the filter. Anyway, and finally, this is the place where you have your waypoint
you sure you
text
want
file.
to give an absolute address? Can't you do a relative address?
It's really complicated.
Really? Oh.
Yeah, because we are sending this to another file, which is within this file system. And it's sometimes complicated to know which is the relative address.
Okay.
So that would complicate the program. We can, I can spend more time making it so that it's a relative address, but
it's okay. So I just wanted to mention that you guys might need to change this address depending on how your file structure is.
yes, we have mentioned this in Monday. This will not work in your computer. You need to change this.
Okay.
But anyway, waypoints 1 here was a small test that we did. So we're going to go for a more interesting test, which is this one. And I believe this one is basically a cross. Yeah.
Why are there 4 coordinates on each line? So that's 0, 0, minus 2, 0.
Oh yeah, this is I think X, Y, Z, and this is the yaw.
Oh, okay. So you're keeping the yaw same.
Yeah,
across.
the yaw is going to be the same across every single. And this is all local, by the way. As in the setpoint publisher first takes in the local coordinates and adds these variables to the first local coordinate. So all of these coordinates are with respect to your initial point. Just take that into account.
That's just 0.5, half a meter, right?
Yes.
Okay.
It should.
So when you say when you say the initial point, are you talking about where we first turn on the vehicle?
Yes.
Or are you talking about a home position that we set?
Wait, no. I'm telling about the place at which the drone is when you first call the publisher.
Okay.
Okay, so let me explain this a bit better in our terminal.
So when we put it in our flight space, we should probably put it or plan to put it at the origin, right?
Not necessarily.
Of our,
okay, hold on. Okay, so when I run this, it's going to read the local position of the quadcopter, and that's going to be the basis. As in, it's going to add all of the set points to that initial position. So the initial position is taken from when you first call this this function. So you can move it around. You don't need to turn it off. It's just that you need to take into account that this is only going to affect the take into account the first position it gets when you first call it.
Yeah.
You can after it lands and the program ends, you can kill this program and then call it again, and it's going to obtain a different initial position
from the current position of the controller.
Yes, when you call this. Okay, so let's see how it goes. It's going to take a couple of minutes to a couple of seconds to start, because I have made this so that it's it can be run. Okay, yeah, and you are going to see first the error.
Can we see the actual simulation?
Yeah, it's not doing nothing right now, by the way. It's only going to start moving once I send the command to do so.
Which is how?
Oh, that's easy. You go to current control here.
Oh, okay.
Yeah, this should be nice enough. And you first have to arm it, and then arm it.
Armed.
Oh, by the way, I didn't change the location file, so it's going to do the easy test first.
Disarmed.
Oh, that's because I didn't arm it fast enough. So what you have to do is basically arm it and then switch to offboard mode. So I'm going to show you how to do that.
Armed. Offboard flight mode.
Yeah, now you see that it's getting the position. Again, this is the I forgot to change the how do I say this?
The name of
The name of
waypoints.
the file, so it's now going to do the easy one.
So which is just go up and come down.
Yeah, go up, move a bit, and then land.
So it's going to wait what, 20 seconds?
Yeah, it's 20 seconds to go to the next one. Yeah, it's now going to go to the next waypoint,
Land
which is
flight
that.
mode.
And now you can see that it changes to land flight mode.
Okay. And the yaw didn't change.
Yeah,
Disarmed.
okay. Now it's disarmed, and we are done with this.
Hold flight mode.
Okay, again, so this was a very simple test. Now that this is done, before I run it again, let's change the weapons to the name of the other one, which is weapons 2. Okay. Okay, so let's see.
Armed. Offboard flight mode.
By the way, this is just a test flight mode, because if we actually did this in the MR, it would probably crash against the how do I say this? The limits, because we have made it go a couple of meters. Yeah, maybe 20 seconds was a bit too much.
So at every corner, it's going to wait 20 seconds.
Oh wait, I remember what the issue was. It's just that the movement is
Very small.
yeah.
Yeah, it's only moving half a meter, right? Can you zoom in the QGC?
Not anymore.
Oh, it is maximum.
Yeah, you can see the movement. Actually, I'm going to land it, and I'm going to make it land and start the test again. Where's the?
Return.
Oh, there's no whatever. Actually, I'm going to just let it run, and then I'm going to run another test after it's done. But yeah,
You can change the text file, right?
yeah, I can change the text file right now. Actually, while I wait for this to happen. Okay, yeah, it was half a meter.
Maybe make it.
How
5.
much? How?
Just make it 5 meters.
Yeah, that's fine. I think this is a cross formation. Yeah. By the way, this is not going to change anything in this run, so.
So return is not going to make it land.
Let's see.
Return flight mode.
Yeah.
Yeah.
But that should ask it to land, right?
Yeah, it should ask it to land.
Once it goes to the safe altitude, it comes back.
Mhm.
Okay. There we go.
Yeah, good call. This one's going to take a while. This time,
Land flight mode.
yeah, you're right. Anyway, this time let's not make it 20 seconds.
Disarmed.
How many seconds? 2, 5?
5 seconds. Fine.
Yeah, let's make it 5. Okay, disarm land
Hold flight mode.
position. Let's run this again. Yeah, I did save to both of those, right? Yeah. Okay, this should be fine. Now let's arm this.
Armed.
Off mode.
Off-board flight mode.
Wait 5 seconds until it goes to the next objective. Yeah, there you go. I'm not sure that's 5 meters, but I'll just wait. No, this is 5 meters. Yeah, see?
Yeah, it is 5 meters.
Well, it's 5 meters according to the. Okay, this is rather complicated. Huh.
Is it running with RCC?
Oh,
I don't think it's running with RCAC.
So these commands are pretty, I think they are very aggressive.
Uh-huh.
Look at the roll angle. It's almost 30 degrees, 20 degrees.
Huh. That's interesting. I could have sworn this was yeah, but it's stabilizing around the position actually.
Well, it's trying its best.
Huh. I'll ask it to return. That's fine with you?
Yes.
Huh, that's interesting.
Return
like
flight
it,
mode.
It did survive at the release.
Are you sure this is not RCC? This is just PID controller?
I'm pretty sure it's the SPID. Actually, I don't know. We should check this out. It did work well for the first.
Look at the PX4 terminal. It'll tell you if RCC is on. Yeah, position controller PNOT is 0.5. That's not changing. I don't know what the second variable is.
Huh, interesting.
I don't think RCC is on in this case. So this was the issue I saw earlier also with the Mavlin set point publishing. It's probably publishing these set points way too fast and it gives a very aggressive command. That's why it's producing like a 20 degrees tilt because it wants to, you know, the reference is too high. So maybe make it slower. Like
Yes.
your set point publishing, make it slower.
Yeah, I was thinking about that.
Disarmed.
So I think just start it again, right?
Yeah, I'm going to start it again because it's how do I say this? Huh, very interesting. This no, this is mavros.
Do you need to cancel all this? Oh, okay.
No, I can just run again.
Communication lost. Manual flight mode. Communication regained.
No, don't worry, it's going to run again.
Hold flight mode.
Actually, just in case, let me disconnect this and then. Yeah, let me rerun this. Yeah, this should be fine.
Hold flight mode. Data link lost. Onboard controller lost.
Oh, not anymore. Okay, this time I'm making it 0.001. It's going to be extremely slow.
Well, we'll see. At least it won't crash.
Okay, let's try this. Oh, wait. Update. Anyway, let's arm this.
Armed. Off-board flight mode.
That's weird.
Huh, should I try a
Never
different one?
changed.
Oh, I made it too small. I made it too slow. Yeah, look, can you see the C error?
Yeah, it's decreasing very slowly.
That's because the
Set points are
yeah,
super
the set
slow.
points are very slow. Yeah, actually, I'm going to yes make it return.
Return flight mode.
Yeah. Yeah, that's the other side of the how they say this.
Make it 0.01.
Yeah, that was too slow. So 0.1 is too fast and 0.001 is too slow.
Disarmed.
Okay.
Hold flight mode.
Oh, wow, it's about to start raining.
Okay, let's try.
Armed. Off-board flight mode.
This is much better, I think.
Yeah, much better.
Yeah, this is a much better response, right? Yeah, we're going to be here at 5. It's going to be 5 seconds, and then it's going to go to the other location.
So look at the roll. It only tilts by, I guess, maybe 3 or 4 degrees. So that's pretty good.
Okay, yeah. So actually, this is a very good reason, or a very good justification of why we're using the filter. You saw what happens when the filter is too fast, and without the filter, what you saw first would happen. So the filter makes sure that well, the change is not so big, because usually big changes in position set point cause that. So what we're doing is making sure that the set point that you follow is how they say this. Yeah, I don't know how to say this, but it's basically to make the trajectory you're trying to follow more feasible.
Oh, wow, it's coming at you.
Yeah.
It's out of the screen.
So by changing that filter, I mean, aren't you effectively changing the response of the position and the velocity control? If
No.
If you
It's not
sort of-
so that filter is not applied to the controller. That filter is
No, I
applied to
understand.
the trajectory generator. So the
Lens
I know.
flight mode.
trajectory becomes slower. So at each
I
time,
know. So if we're
Disarmed.
stringing a bunch of points in the trajectory,
Mhm.
and we're sampling those slower, right? So as
Mhm.
we're going along,
Mhm.
effectively, what we're going to do is we're limiting the response that you could get from the velocity control. So if we just issued one point that was a long way from where we are,
Mhm.
then it would rely on that velocity controller to reach max speed, take us
That's
to where
right.
we are, and then stop.
Yes.
Right.
But by stringing these points kind of close together in
Mhm.
position,
Mhm.
we're effectively removing that velocity control because we're just reaching an angle based on the error between that small error in
Mhm.
That's
position, right?
Yes.
That's right. That's right. A slightly different way of saying it is basically that at each point. So now if you give it a final point, like this is your initial point, and then you give this as the final point, that's a huge error. So at that instant, the errors that are, so the controller is going to react to the errors, and that's a giant error. And giant error is going to produce a giant response. Now, if instead of doing this, you're basically populating this line space with small increments. So at each point, your error becomes small. So your controller response is also going to be smaller. So that's exactly what actually you just said, but slightly different.
Yeah, initially, I guess when we were talking on Monday, I was thinking that the waypoint publishing was like you could just publish the end goal and it didn't need those intermediate points. But it seems like you really do need those intermediate points along
Right.
the path
we're
to where
still-
you're ultimately trying to go,
We're
right?
still setting end goals. It's just that we're doing so in a manner that doesn't cause the quadcopter to overshoot.
No, but the interpretation
Sure.
is that we are issuing those waypoints in smaller step at a slower speed. So they are smaller and they are also slower.
Yeah.
Yeah.
That's it.
Yeah. So that's basically it.
And
Anyway, I'm kind of glad that that first of the first response, because that justifies the use of the
yeah,
of the filter.
yeah, we definitely want to show you the bad cases first so that it's motivating to see why we do what we do.
So yeah,
Yeah,
you can
absolutely.
change basically this so that to increase how let's say how big the sampling is,
Mhm.
and thus increase the velocity at
Yeah.
which you go to the
Yeah.
to your waypoint.
Yeah, and this is really the planning part of the problem. This is not really the control part of the problem, right? So this is issuing the trajectory which the controller is going to follow. So
Yes.
we are essentially saying that, wait, our controller is going to do well, but only if the trajectories are reasonable. And for this value of this alpha field, we are sort of saying that, based on numerical observation, our trajectory is going to be nice enough, or the planned trajectory is going to be nice enough that the response is going to be good. So now this we did in the SITL. It's assuming, so in SITL, it doesn't matter where the states are coming from, right? It's essentially a computation. So your states are available to you. Now, when you're doing it indoors, then the states are going to be coming from the mocap system, right?
Yes.
So that's why we need the set point publisher, because indoors there is no GPS to give it waypoint locations. The only way you can do it is by using mocap.
As far as we know, QR and control doesn't have a way to issue commands indoors.
So that's why we have to do the mocap.
Yeah, we need to
mavros.
use this mavros setpoint publisher in order to issue commands.
So if you guys can get this working with your system, it means that you can issue, you can basically fly the quad rotor using PX4 on a PIXOC board indoors, essentially in your lab, and then switching on our CAC is just basically a flick of a switch.
Yeah. Okay.
Yeah, so it seems like things are getting clearer, right?
I think it's much more clear for me. Yeah.
Yeah, that's great.
Okay, so this was it for the setpoint publisher. Is it okay if I just stop the video right now?
For recording, you mean?
Yeah, the recording.
Yeah, I guess so. Nope, more.
Stop, right?
Stop. Yeah.